Okay, so this is the second online session of the summer semester 2020. Let's start off with questions. Does anybody have any questions so far? I mean, I realize we've only been in class for what is it, 2 weeks now, or is it just a week? I guess this would be the second week. Yeah, that's why it's the second online session. Wow, he is smart. Oh man, I tell you, I'm so tired. Any questions, comments, wants, needs, desires, concerns, complaints? Welcome. Y'all noticed that assignment one was graded. If you didn't notice, assignment one was graded. I uploaded back your files. I did go through them. I did not check every single problem for accuracy. I did what I normally do. I ran your code. I know the output should be, if it was right, I just continued. There on assignment one, there are three problems that I do look at because they're ones that students struggle with the most. Um, um, what? I gotta get rid of this. Um, oh, this is a command window, so we can get rid of that. So one of the problems that students struggle with in that chapter is problem 3, I think 312 and 311, 310, something like that. It's the log space. Um, the log space command. This command will allow you to space, create an array of numbers that are logarithmically spaced between a starting number and a finish number and however many variables you want. And so if you're trying to go between 10 and 1,000 and you want 6 numbers, I see this all the time in the homework because that's what the problem asks for, is between 10 and 1,000 with 6 variables. However, with the log space command, these inputs are the log of that input. So this would be a 1 and this would be a 3, and that gives you logarithmically spaced values between 10 and 1,000 with 6 of them. You see, if you multiply this out by 10 to the 3, you'd have 1 to 1,000 logarithmically spaced. Okay, so what I see a lot of is like I say, the 10, and another one on the on part D of, I think it was 3.12. 3.12. I think it's 212. Oh, would you be quiet? You are annoying. Sorry, I need to turn this down. The log space also works well if you spell it right with decimals. Okay, so there's one problem where you had to go between I think it's point 0.1 to 0.001. And some numbers. Okay, again, you gotta put the log value of these numbers in. So this one would be a -1, and this one would be a -3. Okay, so this is a problem that a lot of students have issues with. Some people say, well, okay, well, I don't understand the log space, it's not working, so they'll do 10 to 1,000 with 6. Okay, I can tell you right now that you'll get two different answers here. Because one is linearly spaced and the other is logarithmically. So this one's 10, 10. Well, that's 251, 208, 631, 406. So it's not have the same spacing. So to get a logarithm, okay, I've beaten that one to death. Anyway, if you got questions on log space, let me know. And then the other one is the last problem. Most of you got that right because I basically did the problem for you on the online session last week. And that's the saving to a data file, clearing the variables, and reloading. So if you haven't had the opportunity yet, go in, check your score on that. If you didn't get 100 on it, there is comments in your code to tell you why. And other than that, I mean, oh, quit doing that. Y'all did fairly decent on that assignment. It was good. Um, so, are there any questions about Chapter 2 or Chapter 3? I guess Chapter 3 assignment is due tonight, is it? Um, I will cover a couple of things involving Chapter 3. Um, one, I guess one thing on Chapter 3, I did send out an announcement that if you were having problems finding the data files for 325, let's get you out of the way. 324. Okay, I will cover 324. Let me finish 325 here. So that link that I sent you takes you to this spot right here. You can come in here and pick a state, any state, I don't care. Get yourself however many years of data you want. Actually, Brittany, here's where you can get the Excel data. Sorry, we were working on that before the class thing started. So
is that an XML file?
Yeah, if you,
Okay.
I think, I don't know. Let's see what that gives us here. If you download it as a text file, oh no, we don't want that one.
I was gonna say XML's
Yeah,
code.
yeah, we don't want that one. Okay, so you can do it either. I'd stick with a space file, delimited. I think I did that the other day too. See, I only have 2 functioning brain cells, and I tend to forget a lot. Um, so when you download this file, it will work. However, there's one problem with it for our this line right here. You need to open up the file and remove that first column, first row, because you'll have problems importing the data. I think we learned. I don't know if we learned that or not. We may learn that in future chapters. At least the 1030 students. 1040 you won't get into it. So once you've downloaded the file, if you just download it to your to downloads here, where did it go? You kumquat. Let's see, the beauty of this recording this is I can edit all this stuff out. Where'd my okay, let's come back, here you go, there we go. Let's click on that again and show in the folder. Oh, it defaulted to my, here we go. So just come into your, that's not it. Date modified. Okay, well, it's not playing nicely. But if you just go into where you've downloaded it, open it up in the notepad, take that column out, and then close it, and then you can open it up and run it inside of MATLAB. Now that I got you totally confused on that problem, yeah, don't waste a lot of time on it. If you put any effort at all, I'll give you full credit on that one. Let me go cover 324 and then we'll go to 320. So 324 is loading in an Excel file. Now there's several ways to load in the Excel file, and I'm going to cover the best way, which is to load it in using code. So there is a command that is XL I want my mama. XLS read, and then the name of the data file, which is this Denver. We're going to cheat and just come down here and copy that and paste it, and don't forget the extension XLSX, and that will give you an error. Don't tell me that. Oh, it's got to be inside of uh, single quotation marks. Sorry. So now because we didn't assign it to anything, it is in this answer format. Trying to find this Denver climate file.
Yeah, I was looking at announcements. I'm not seeing it.
The Denver file is if you go to the homework assignment page, it's right here under thermocouple. There's the Denver for this problem. This file right here is for 324.
Okay, I knew I found it. Thank you.
It's the one for 325 where it tells you to go onto the website and spend an hour going through their website trying to find where they've got this data. So you can assign this to a variable here, and then when it comes in, you now have a variable called data. And if you look at data, it loads it in and assigns it to that variable. The only thing is you got to know which column has what data in it. So yeah, and you can get that just by opening the file in Excel, and that would be this file here. So it goes through and pulls out all this stuff and just gives you the numbers, which if that late comment, so you can't figure out how to download the file for 324. I'm on a Mac anyways. Yeah. You know what? Don't. Okay, you didn't hear this from me, but don't worry about 325. I'm not going to grade it. It's a bad problem. It covers issues that really hasn't been covered in the chapter yet. Going to a website to find data is ridiculous. So if you've done it already, maybe I'll throw in an extra point or two. But we do get into Excel files again later on in the semester, where I think it gives you a little bit more info on how to operate. Although, if you go to our Canvas site here and go to the home page and the videos from online session. Oh no, that's the welcome video. Where is that? Oh, I know where it's at. No, you're fine. I'm easily derailed. I think it's in. Where is that? I seen it in here. Start here. That's not where we wanted to go. Is it in the modules? Instructions. Alright, class. I know well, you know what? I'm going to find it and put it on that page. But I created a video that shows how to. I bet that's where it might be. It might be in the announcements. Saving files, data files, loading Excel files into MATLAB. Has that been posted? Yeah, it posted May 22nd. So in here, there's a video that shows you how to load data files, and that covers .dat, text, and Excel files. So if you get a chance, go into the announcements and take a look at that. You can copy and paste the data set into MATLAB. Just be aware that I wrote a problem once that I took some data from the bench testing I was doing at my work, and there were 8 columns with about 1,400 rows of data, and something like that. It's a very huge nuisance to copy and paste that into an Excel file. because it just makes it so long and trying to scroll between problems. You had troubles after saving. Did you save it as an ASCII2 file?
Did I save it as, sorry, what file?
Well, just I'm looking at the chat window. Are you viewer 6? Someone had trouble loading it after saving it, and I'm not
Yeah.
sure.
Yeah, I said that.
Okay, that was you. So, how did you save it? I mean, was that when you were working inside of MATLAB or outside?
I saved it outside. That's
Okay.
what I did.
Okay. Um, I'd have to see what you did to it.
Okay.
So, okay. Yeah. So stick around afterwards, and we'll get back to that. Okay. So 321. Any questions on the data on Excel files? Um, Actually, that video in the announcement does cover Excel files. Um, what am I doing with my phone? Oh, I was trying to pick up my textbook, and I got my phone instead. Wow.
I have a question on
Sure.
the actual question of 3.24, I guess.
Okay.
So part B, I mean, I just don't know what it's really asking for. Find the average, monthly, mean, minimum. So are we finding the minimum average or just the average or just the minimum? I'm not really sure.
No, it's like I say this. It wants you to find from uh, this column right here what the monthly mean temperature was.
Okay, so just the mean then?
Yeah.
Okay, perfect. Thank you.
Yep.
For the uploading the Excel file, you said that like your equation doesn't really line up with the video that you gave us. Like it was like load something and then your file said like XLS.
Yeah. The load command works on .dat and .text files, but for
Okay.
an Excel file, you have to use the XLS read.
Also for that question, is it fine if I just put in like TPCP equals and then I put in like that column of numbers in the matrix and then I just said like sum of that?
Um, you can do that, but I highly recommend because outside of this class, you're going to be loading in data files from if you're doing research or anything like that. You need to know how to bring in these data files. So it's best to learn how to do it. Um, I mean, this
I
is
understand how to upload it, but I just don't understand how to later use the data that's
okay.
inside to
Well,
solve the
well,
problem.
let's cover that. Okay, so this we've loaded in this data file, and we have. Okay, well, let's look at the first problem. A is the TPC, so that is column 4. So TC, what is it? Oh, TPCP is equal. So now to set the values in that data, this brings us in as a matrix right here. Um, and hopefully that's right because them are a bunch of zeros, but it could be I just have a bad data file. So what we need to do now is take all of the values from column 4, right, because that's our file, and assign them to this variable. So the name of that data file is data because that's what I assigned it to when I loaded it in. So we're going to tell it to go to the data file variable, and we want to assign TPCP all the values from every row, and we tell it every row by doing a colon, and then we do a comma to separate, and we tell it which column we want. Well, it was column 1, 2, 3, 4, so column 4 and close parentheses. Now this is going to go to this matrix, and it's going to go to column 4 and take every row and assign it to this variable, and it's right there. So now you can, for this problem, it wants total precipitation. So I mean, we can nest. You can nest commands in MATLAB, and we can just tell it to sum all those things in that row, and it will add them all up for you. Or you can do it in 2 steps. Does that make sense?
That was for A, the total precipitation?
Yeah.
Oh, there I see it. Okay. What part of the problem was for finding the 4th column? Oh, I see what you did. So you're looking for, you showed us the 4th column with
Yeah,
the
well,
colon.
part A wants you to find the total precipitation of 2,000 feet using TPCP column, which, according to looking at the table at the bottom of the book, is column 1, 2, 3, 4.
Gotcha.
And that's where the 4 came from. Okay, any more questions on this? Oh, 321, okay. I know 321. This is one is actually part of the one of the things I was going to cover tonight, so it's a good thing you asked me for it. Are there any more questions on 324, 325 before I move on? We can always come back to it later. I mean, there's nothing preventing us. Okay, so 321, we're creating a fictitious temperature range of 240 values. So it tells us to create a normal distribution of temperatures with a mean of 70 and a standard deviation of 2 corresponding to a 2-hour duration. You'll need a temperature for each time value from 0 to 120 at half-minute intervals. Okay, so first off, let's do our time, because that's the easiest thing to do. And we're going to go from 0 by a half-minute interval to 120, right? Okay, and I don't want to see that, so we're going to suppress it, and we're going to clear our variables and our workspace before we get started. Let's see, 1 by 241, so so that gives us 241 variables, temperatures. So now we need to make our random temps. So our temps is going to be, and then we're going to use the rand n because it wanted the Gaussian distribution or normal distribution. Now the inputs to this, if you do a single input of 241, it will generate a code, but if with a single input, it will give you a matrix that is 241 columns wide and 241 rows deep. It'll be a square matrix, which is about 241 times the number of data points that we actually want. So we're going to make this a row vector. So we're going to tell it we want one row with 241 variables. Okay. You could also do it the other way, 241, or there's several ways to get that, but just remember that a single input will give you a square matrix of that size. That becomes an issue on another problem where there's like 10,000. It wants you to do 10,000 random numbers, and if you just put 10,000, that's 10,000 times 10,000. That's a lot of numbers. Um, and then we want to have a standard deviation of 2. So with the rand n, if we multiply that output by 2, that'll give us our standard deviation of 2, and then a mean of 70, so we'll add 70 to it. So that'll give us numbers that are within the range that we want, and we can test that by doing just checking the STD, which is a standard deviation, and the mean. You guys may not have had these commands yet, so I don't expect you to do this. I just do this to make sure that what I'm doing is it's matching the data that's asked of me. Yeah, 10 by 10. Yeah, I can imagine that. So our standard deviation with this random number generator is 2.1 with a mean of 69.9. So this is generating the random set that we want. Again, this isn't required. I just do it because I like to. Okay, so we've done that. Part B, plot the data. Okay, so we'll plot, and we'll just do a simple plot. I won't expect you to do labels and titles and all that other good stuff. You'll learn that in chapter 4 coming up very soon. And temps. So here we'll get us a nice neat little plot, and we'll just park that over here. Go away, I don't want you. And now every time you run that, that's going to change because the random numbers being generated. So if you're easily amused by this, you can sit here and watch this for hours. Probably never get the same plot. Okay, so there's part B. Part C, now this is the one where students have trouble because this is the first time you encounter something like this in this class. So it wants you to find the maximum temperature and the minimum temperature. Those are the easy parts, and the time at which they occur. Now that's where it gets a little tricky for students. So we know that if we do max temp, I thought I turned you off, and we take the max of our temps, that will return the maximum temperature. Okay, 76.33, and again, you know, that's going to change every time we run this because of random numbers. Okay, and then if we do the min temp equals min of temps. Oh, come on, I turned you down. Where did you go? I may have to throw you outside. My apologies. There we go. Okay, so now we're getting the maximum and the mins, but that's only half the problem. It wants to know when they occur. So that's when we do a little tricky thing here with our max and min callouts. If we take the output from this vector or this function and assign it to two variables, I'm going to say max location, and they're in square brackets, comma, min location. I think I forgot an L. Okay, so now when we run that, the max command is going to return two outputs. The first one will give us the maximum value and where it's located within this vector. So now we see that the maximum value is the 68th variable, and this one here is the 217th. Okay, so that just tells us the location. That doesn't tell us the time. That tells us the location, but it's nearly there. Now a lot of students will go this far and then they'll say, okay, well, that's 124 is not right. Well, we got to take and divide that by 2 and add a half to get the time. No, what you do to get the time is you go back to the time vector and find out what value is in the same location as the maximum. So the maximum time is 9 seconds, and we should be able to get to, there's a half a second there. Okay, does that make sense? Any questions, comments? Oops. Yeah, how come you can't do it right? Because I'm stupid. Max temps, I want max time, you idiot. Min time equals time of the min location. So there's your times for the max and the min. And that works for just about any time you want to use the max and min. It also works with the median, mean, most of your statistical functions. Just be aware though that that's a different, there is a problem coming up. I don't know if it's in this one or is in the next one, where you need to take the standard deviation of a matrix, and it wants to know the standard deviation of the entire data set. If you do the standard deviation of the data set and then take standard deviation of that, you've got the standard deviation of the resultant vector, not the yeah. Okay. Questions? Did that answer your questions on 321? Did I put everybody to sleep?
For some reason, my computer gives an error when I put that code in. The last part.
The last one? What's the error it's getting?
The last part. It says check for missing argument or incorrect argument data and call to function time.
Is there a time function there? I don't know. Time is a variable of type double. Let's clear everything. I don't know if oh, there is a function for time. Wow, cool. Probably not ought to use time then here. Oops. Time and do a shift enter, and now I got T's. Try changing your variable name and see if that'll fix it.
Okay.
Although the time is not a hard function where you can, you can assign, like I just did, a value to a function. However, if you try to use that function before clearing it, it won't work. Like here, I could reassign max. Oops.
So for the minimum time, it says 96.5.
That's the time of the minimum, I'm assuming.
Okay. So I think it works with the T's.
Cool. Okay. What else did we have on board for today? Trig functions. Trig functions in MATLAB are in radians. So if you theta equals let's say 45 degrees, and you try to take the cosine of theta, that's not right. But there's several ways that you can do this to get the output into degrees. There's the I'm tired. You can multiply degrees by pi and divide it by 180, and that will give you the proper answer in radians. because this is now in radians. Or you could do degrees to no yeah degrees to radian, degrees to radian. Is that right? I don't think that is right. Oh no, sorry. I don't use this command because it's too many extra letters. There we go. Degrees to radian. This will convert whatever this input is from degrees into radians. But the easiest way to do this, we'll just comment that out, is to add a d at the end of your trig function. Cosine d. That tells it to do it in degrees. What are you doing clear up there, you kumquat? So of all the options there, to me this is the easiest one to do. Just add that extra little d right there, and that works on the sine, the cosine, tangent, cotangents, cosecants, all of the trig functions. Yeah. So believe it or not, I've covered everything that I had planned to cover for tonight, and we did it in 39 minutes. It may have seemed disorganized, but we covered everything. Let's see, we covered the data file. Now I have one student tell me they're having problems saving files on the web-based MATLAB. Is there anybody else having that issue? Okay, that's a good sign.
I had that issue, but then I just downloaded MATLAB, which took 48 hours.
Oh, good grief. I'm so sorry. Yeah.
I actually did get it. I got it while you were talking.
You got what?
The Excel file saved and loaded in there.
Okay, cool.
Yeah.
So you got it all figured out, so we don't have to stick around, or?
Yep. Yeah, I do. I got them all computed now. So that's
Okay,
good.
cool. So okay, cool. Yeah, one of my students contacted me just about 6 o'clock tonight, telling me that 3 times today they saved their file, and then when they went to go get it, it was gone, and it was on the web-based. And I don't understand why it would be gone. It should stay in, because you're logging in to your account, so it should stay on your cloud. So I need to look into that. They're getting very frustrated in that they've had to redo the assignment 3 times, and I completely understand. The students, those of you that are in 1030, you should be getting an email here shortly from your 1035 instructor, and also once they finalize the email, I will send it out to all the 1030 students in my class regarding the lab. It looks like we're trying to schedule for the 15th. I'm guessing the 15th of June, because the 15th of May is already passed. To have you come over to the Redwood campus to pick up your Lego robot materials. Once I have more details, I'll send them out, and also the instructors from the labs will do that. So be on the watch out for that. Yeah. So has anybody tried typing Y in the command window yet? No? You guys must not be bored yet.